Good morning, third grade boys and girls. I'm so glad to see you this morning coming and checking your DMA. That's a super responsible thing for you to be doing. I am so proud of you. Let's go ahead and take a look at our problems for today. We have 3 problems that are related to our multiplication facts here. We're using division to help us find a missing factor. Remember, when you're multiplying, these are called factors. And the answer to a multiplication sentence is a product. Now, our product actually is right here in this division sentence. So, I have 3 groups of something, and those groups are going to give me a total of 18 total objects. So let's go ahead and take these 18 objects and put them equally into 3 groups, especially if we don't know our multiplication facts. If we do know our multiplication facts, then that's going to make it easier to find this missing factor. So let's take a look at, we have 3 groups. We don't know how many is in each group, but once we divide these 18 objects equally into these 3 groups, then we're going to find our missing factor. So I'm going to start by counting by 2s since this is an even number. So I'm going to go 2, 4, 6, 8, 10, 12, 14, 16, and 18. I think I needed to make my groups a little bit bigger, but we still were able to see that I have 2, 4, 6, 2, 4, 6, 2, 4, 6, and I'm going to have 6 objects in each group. So when I take 18 divided by 3, it's going to give me 6 objects in each group. So my missing factor is going to be 6. All right, let's take a look at my next problem. I have 4 groups of blank equals 20. So we're going to use our division to help us with our multiplication missing factor here. So again, these are my objects, all of them. It's not 20 in, it's not 4 groups of 20. It's taking 20 objects and dividing it equally into the 4 groups. So we can't just put a multiplication symbol here. We have to use division. So I'm going to have 4 groups, and then I'm going to take these 20 objects and share them equally into the 4 groups. So again, I could count by 2s. 2, 4, 6, 8, 10, 12, 14, 16. Okay, now I'm getting close to 20. So I'm going to go by singles. 17, 18, 19, and finally 20. How many objects do I have in each group? Right, I have 5 objects in each group. So if I take 4 groups, 1, 2, 3, 4, and I take 5 in each group, I'm going to get the 20 objects that I started with in my division sentence. All right, let's take a look at this last one. I have 45 objects. I'm going to take them and put them into 9 equal groups. And if I know that this is 45, 45 is a multiple of, yeah, you guessed it, 5s, right? Anything that has a multiple of 10 or has a 5 in the ones place, it should be a multiple of 5. So we should know that, right? So how many groups of 5 does it take me to make 45? Well, let's see. 5, 10, 15, 20, 25, 30, 35, 40, 45. How many groups of 5 did I make? 9 groups of 5. So again, remember when you can use the order of operations to help you figure out 5 groups of 9 is the same as 9 groups of 5. 5 groups of 9 is the same as 5 groups of 9, which is still going to give you a total of 45 in the end. All right? Let's take a look at our word problem for today. We have a word problem. Let's see what we're going to be doing with that word problem. It says Jamie had 4 packages of stickers. Sounds like groups to me. And it says each package had 4 stickers in it. How many stickers did Jamie have? Well, if I have 4 packages or packs, and each pack contains 4 stickers, this sounds like what kind of problem? Yeah, multiplication, right? Because we know our groups, right? So let's think about what we're doing here. We know our groups. Do we know the number of objects in each group? Yes, we do. We know that there are 4 stickers in each pack, right? And are we looking for our total? Are we looking for all the objects put together? Yes, it says, how many stickers does he have? So that does tell me that I'm going to be working with multiplication. So my groups are the packages. The objects in each group are the number of stickers in each pack. And my total objects are going to be how many total I have put together. So if there's 4 stickers here, and we're looking for total stickers, right? Total stickers. And there's 4 stickers in that pack. And there's 4 stickers in this pack. And there's also 4 stickers in that pack. Then I can add 4 plus 4 plus 4 plus 4. And 4 plus 4 is 8. And this 4 plus 4 is going to give me 8. And my total number of stickers is going to be 16 stickers. So I have an equation. Here's my equation. I'm going to fill in my total, which is 16, right? 16 stickers. And I have a model to show my work and how I worked it out. So, nice job. We're going to fill that in. So we have 4 groups of 4. 4 groups of 4 gives me 16 stickers. And I have my model already on my paper, so I should be good. Now, my next problem says perimeter, not area. Notice this would be a very difficult problem to do area with. Not that we couldn't do it, just makes it a little complicated. Because we could figure out how many square units are inside the shape. By the way, what shape is this? What is the name of this shape? That's interesting. Is it a quadrilateral? Well, let's count the sides. 1, 2, 3, 4, 5, 6. No, it's not a quadrilateral, because remember, quadrilaterals have 4 sides. 4-sided figures are called quadrilaterals. So it's not a quadrilateral, but it does have 6 sides, right? It's a 6-sided figure. And what happens when we have a figure with 6 sides? Well, 5 sides is a pentagon. 6 sides would be called a what? Right, a hexagon. This is a hexagon. Why is it a hexagon? Because it has 6 sides. Now, all the sides are not the same length, but that's okay because remember, not always are we going to have a figure that has the same length of sides. But if it's a six-sided figure, it's a hexagon. So now we want to figure out what is the perimeter of this shape. Perimeter means we're going to find the length of all the sides together. So on your paper, I want you to write length of sides. And this is called the what? The perimeter. What's it called? Perimeter. The perimeter is how many inches, centimeters, whatever we're measuring the length of those sides, how long does that have to be? So if we were going to take and lay out a piece of string along these sides, then we would need to know how long our string needs to be able to put it all the way around this hexagon. So let's go ahead and use our addition to find the length of the sides. So I have 3 plus 4 plus 1 plus 6 plus 2 plus 4 plus 3. You're like, how did you do that, Miss Hanmiel? I can see through the paper if you didn't notice that. All right, so now let's do some combining of these addends. These addends are going to be easier if I can put them together. So 4 plus 3 is 7. And, I like 6 plus 1 is also 7. And another 4 plus 3 here is going to be 7. And then this 2 by itself is going to be by itself. But that's okay, because I have 3 groups of 7. And if you know your multiplication facts, 3 groups of 7 is, right, 21. And these 2 more are going to be together 23. So it doesn't tell me what the length the units that I'm using to measure, but it does tell me that I do have a length of putting these sides together as 23. So I'm just going to put 23, and then I'm going to put length next to it. Now, that length could be inches, it could be yards, it could be miles. It just depends on what unit of measurement we're using, okay? And finally, we're going to take a look at a fraction problem here. And we want to decide if these fractions are equivalent to each other. Maybe they're less than, maybe they're greater than each other. Well, let's take a look. I have one full circle, and it's broken up into 4 equal pieces. That tells me, and we're going to write this fraction down, that my denominator is fourths. Now, we're going to assume that we're talking about the shaded parts of this whole, right? The shaded parts. So I have 1 that I can count that's a shaded part for my numerator. So my denominator is 4 because I have 4 equal parts in the whole, and my numerator is 1 because I have 1 of the parts that are shaded. That's what I'm counting, the shaded parts. Now, looking at this model, if you look at this model, it looks very similar to what's happening up here, doesn't it? Well, let's think about it. Does this piece match the piece that is here? Does this piece match the piece that's here? Does this piece match this part that's here and here for this piece? Well, if you said yes, you'd be correct. But instead, we are breaking up the whole into how many equal pieces? 1, 2, 3, 4, 5, 6, 7, 8. So our denominator is now eighths. Now, what you did here was you took each quarter or fourth and broke it up into 2 pieces. Took each quarter and broke it up into 2 pieces. Took each fourth and broke it up into 2 pieces. So this is an eighth, this is an eighth. And that's compared to this 1/4. There's 1/4 here, And again, we took that fourth, we cut it into two pieces. This is an eighth, and this is an eighth. So remember, it takes 2/8 to make 1/4. 2/8 to make 1/4. So are these equivalent? Yes, these are equivalent to each other. So make sure that you show this equal sign between the 1/4, which is here, and the 2/8, which are here. And yes, these are equivalent to each other. Now, I want you to, for your discussion today, I want you to look at the unshaded parts and write an equivalent fraction for the white unshaded parts for me today. So in your discussion, you are going to write for the discussion, what are the fractions that are equivalent to the unshaded parts? Unshaded means the white parts, okay? I'm going to be looking for that later on, and we'll see how you do, and have a great day. I will see you soon in our live meeting. Bye.